Analytical techniques in chemistry often have very intimidating names. Spectroscopy is no exception to this. Let's talk about topic 3.11, spectroscopy and the EMR. So first of all, we have to start with what is spectroscopy. A very casual definition is basically how molecules vibe with various forms of electromagnetic radiation. So basically, we are probing these molecules with photons and seeing how they respond. Next question is, what is EMR? EMR stands for the electromagnetic radiation. So basically, it's just this energy that travels as waves. We have a spectrum. We often arrange it in order of increasing or decreasing wavelength. So I've shown it from short wavelengths down to the longer wavelengths. You have to remember that the wavelength and energy are inversely related. We care about this because each form of spectroscopy is going to use some form of EMR. Because when molecules interact with EMR in a specific region, they undergo specific transitions. Believe it or not, you've already studied one form of spectroscopy with photoelectron spectroscopy in Unit 1. Love it or hate it, you have been exposed to it. Please note that mass spectrometry is not the same as spectroscopy. But in this Unit 3, you're going to be looking at IR and UV spectroscopy. Now, to understand what's going on there, we need to talk about molecular motion. So I want you to imagine three scenarios. Stretching a spring, spinning a top, watching something like a frog jumping. Each of these represents a different form of molecular motion. The spring stretching represents vibrational energy, the top spinning is rotational energy, and the frog jumping is an electronic energy. So that represents the excitation of those electrons. And I know this is such an elementary approach to spectroscopy, but this is what you need to know in AP chemistry. You need to remember that rotational energy is less than vibrational energy, which is less than electronic. And then you can match that with the type of spectroscopy associated with each type of molecular motion. The lowest energy will also be the lowest energy form of EMR. So rotational energy is what we use in microwave spectroscopy. We're looking at vibrational energy in IR spectroscopy, infrared, and then we're looking at those electronic transitions in UV-vis spectroscopy.